Okay. The lesson I'm going to give you today is called conditional probability. And you will see over here written on the whiteboard the objective. And I want you to see that notation right here. Probability of B given A is equal to probability of A and B all divided by probability of A. Okay, and then there's the other one. You can switch it around. Probability of A given B is equal to probability of A and B all divided by the probability of B. I'm going to explain what this means. But you need to know this symbol right here. See this symbol right here? A little slash? It means given. Or one of the material I was reading uses the word assumes. Now I've got to tell you, I've taught math for 22 years, and I have never taught conditional probability before. I'd heard of it before, but I'd never taught it. And yesterday, I spent 3 hours after school, 2.5, 3 hours after school, learning about it. So I want you to know I'm kind of learning along with you guys today. So be a little patient with me if I fumble on this a little bit, because I've never taught it before. I understand it. It's hard to formulate in your mind how to teach something if you haven't taught it before. So kind of, if you guys get confused, ask questions, okay? So, yeah, JD.
If they've been teaching not this for how many years? What makes...
Well, it's been taught. It's just never been in our curriculum. See, I've taught probability quite in depth in my Algebra 2 and my pre-calculus classes before, but I've taught a lot of probability, but I've never heard of conditional probability. So, probability is a confusing subject once you start getting deep into it, because there's so many different things that come into play. Like, what's the probability of this if this, this, and this happen? Okay, and so it can kind of get confusing after a while. And there's a lot of terminology and words that they use, but the reason I figured out the reason, I kind of think the reason that we've never taught it is because it can also be called dependent probability, and I've taught dependent probability before. Because just like that last problem you asked me to do, the 65 out of 100, and 63 out of 99, and so forth, that's dependent probability. That's what it is, except for they give it this different notation. They give it this notation of probability of B given that A happened, okay? And so, and they come up with this difficult notation, and it allows you to do more difficult problems is all. So it just goes, it takes dependent probability a step further is what it does. So it is used, and I can see where it's used, but it's not right there. So, okay, we're going to go on with the lesson. By the time we're done, you guys are going to be able to understand this notation and how to use it. The assignment is actually quite easy. The 5 problems, once I teach you how to do it, will take you less than 5 minutes to do it, okay? It will, seriously. It will take you less than 5 minutes. It's only 5 problems on your assignment. What was that? Unless I talk the whole time? Is that what you said? What? I can't hear you. That's all you're going to do. Okay? All right. So, here we go. Okay, yes? I'll give it to you in just a little bit. I want you guys listening while we're doing it so that you get the notation, because you can do this without the notation. I want you to understand the notation. Okay? All right. And I'm going to give you guys, I'm going to give you kind of an intuitive idea of it, first of all. Okay, let's say I have a bag with 5 marbles in it. Okay, these are marbles. Okay, there's 2 blue and 3 red marbles. Okay, Michaela, what's the chance if you reach in there of pulling out a blue one? 2 out of 5. So I'm going to write this right here. Hi, guys. She is. Thank you. Okay. That's loaded full of cash. I saw it, you guys. Mug Jenny on her way out. No, just kidding. Okay. It's really not. Okay, so here's that chance. There's a 2/5 chance of pulling out blue marble. If that happens, how many marbles are left in there? What color? Okay, 3 red and 1 blue, right? All right, but what if we pulled out? That's right, you're colorblind, aren't you? Those are the 2 blue ones there, and that's a blue one. Can you not tell the different shades of them? Okay. All right.
I was like, yeah.
All right. Okay, so next, what's the probability, if I, just going back to the start, what would be the probability of pulling out a red? 3 out of 5, right? Okay, but what if we all of a sudden we take this a step further? Oh, by the way, if I choose a red one this first time, what's left? Okay, now we're going to go with this one right here. We're here. What's the probability, Trayson, of pulling out a blue one right here?
1/4.
Okay, 1/4. What's left?
3 red.
3 red and, okay. What's the possibility right here, Hunter, of pulling out a red right on this one?
3 out of 4.
3 out of 4. What's left? 2 red and 1 blue. Okay. Going down here. Okay. Sam, what's the probability of pulling a blue one out of this one? 1/2. What's left? Okay. What's the probability right here, JD? Pulling out a red. And what's left? Okay. Now I'm going to ask you guys a question. We're going to start at the top one right here. Okay? Jenny, what is the probability that I'm going to pull out a blue the first time and a blue the second time? Okay, let's go. Go, Tyson. 2/20. How did you get that? Yeah, let's write that down. Good. Okay. There was a 2/5 probability of pulling out a blue on the first one, right? And then after that, there was a 1/4 chance of pulling blue on the second one. Just like independent probability, if there's 2/5 chance on the first one and 1/4 chance on the second, we multiply them together and you get a 2/20, which is 1/10 chance of getting that. You understand that? Okay. Eli, what is the chance of choosing a blue marble first and a red marble second? A blue marble first and a red marble second. 6/20. That's right. Because how did you get that? 2/5 times 3/4, which is 6/20, which reduces to 3/10. We getting this? Okay. Stephanie, what's the chance of pulling a red marble out first and a blue marble out second? Okay, and how did you get that? 3/5 times 1/2, and you get 3/10, sorry. Okay. Cole, what's the chance of choosing two reds? Red on the first and red on the second. 3/10. How did you get that? Three-tenths. Okay, good. By the way, you guys, what's the probability of pulling two marbles out of here? If you reach in and grab one, and then you reach in and grab another. 100%. What do these add up to right here? 1/10 plus 3/10 plus 3/10 plus 3/10. 10 out of 10. They should add up to 1, right? And they do. 10 out of 10, which is 1. All right. Now, this is where we get into the notation right here. You guys, I'm gonna give you guys 4 scenarios. A, B, C, and D. Okay. A is the event of drawing a blue on the first draw. Okay. This one's the event of B is the event of drawing a blue on the second. C is the event of drawing a red on the first. D is the event of drawing a red on the second. Okay? Now, this is where you got to really listen to the notation right here. Okay? I want to know what is the probability of B given A. JD, what do you think? What's the probability of B given A? That's right. This one's lost over here, so you go ahead.
Blue first and blue second, so it's 2 and 1.
Which is 1/10, right? Okay, good. The probability of B, of getting B, given that A happened. See, here's A, you guys. This is the probability of A right here. Okay. This right here is the probability of B, right? Does everybody understand that?
And that's probability C of 3/5.
Okay, and yeah, 3/5 would be the probability of what? This is the probability of C. Okay. What's this right here? That's the probability of D, right? What's this the probability of? Huh? B. This is the probability of B. What's this one? This is the probability of D. Okay. D. Yeah. Okay, so let me ask you guys this question. What's the probability of B given C? Talon, what do you think the probability of B given C is? Wait, that's Talon. C is the event that you drew a red one first, and B is the event that you drew a blue one second. It's be 3 out of 10. Why? Yeah, it's this one and this one, right? I want to know the probability of B given that C happened. That's a probability of B given A happened, right? Got it? Okay. Coulter, what do you think the probability of D given C is? And which one are you going to follow?
Very bottom.
The very bottom one, right? Here's the probability of D given that C happened, right? 3/10. Okay, D given A, okay? Wait. Oh yeah. Probability of D given A. What's the probability of D given A? Wait. Probability of D given A. Yeah. Yeah, you can, right here. D given A. 3/10, right? We kind of get that so far? Okay. All right. Now, let's talk about this formula right here. Let's give you this formula right here. The probability of A and B happening is equal to the probability of A. You know what? I probably wrote that a little bit wrong right here. Let's go back one slide. You guys, this is not the probability of B. This is the probability of B given A, the whole thing, right? This, I should have written this one as the probability. This one should have been the probability of D given A, right? This one should have been the probability of B given C, right? I mean, probability of A given C, right? And this down here should have been, instead of that, should have been the probability of D given C. Okay? Yeah, not A, probability of B. Yeah, B given C, you're right. That's probability of B given C. Okay, so you guys, look right here. I want you to see this. Here's the probability of A. Here's the probability of B given A. I multiply those together. 2/5 times 1/4. I multiply those together. Here's 2/5, and here's times 1/4 to get the probability of B and A happening, right? 2/20, which is 1/10, right? Okay? And that's how you get that. And so this is what we're trying to do today, is to find, and I'm just showing you this, the probability of A happening first times the probability of B happening given that A happened is 1/4, and you times those together and you get 1/10, and that's the probability of A and B happening. Does that make sense? A and B are going to happen. Now, we're going to take this formula right here. We're going to take this formula right here, and what would I do to both sides of this formula so I can get it to look like this one that's over here on the whiteboard? P of A, right. We're going to divide it by P of A. If I divide this by P of A, Jenny got it right there, P of A. They cancel out right there, right? And I'm given the probability of B given A is equal to the probability of A and B, the intersection, in other words, divided by the probability of A. That is our notation. Now, I don't know if you guys noticed, this is much simpler than doing it without the notation, right? But there's some reasons we learn notation. One is so that when you get on more complicated problems, you can use these formulas to do them. And number two, thank you. And, oh, he's not here today.
What are those?
Okay. And the reason we learn them is so we can get, when we get more complicated problems, we can do it. And that we can also use them to make proofs of things, okay? And that's where it comes from. So we're going to learn how to apply it right now. So everybody, pull out your assignment. Oh, did I not hand them out yet? I'm going to hand them out real quick. Okay, hey you guys, the first page of this The first page of this kind of explains what I just showed you. Okay, so I now want you to go, turn it over to the second page, page number 2. Look at where it says example 1. Is everybody there? Go to example 1. Okay, it says a jar contains black and white marbles. Okay. 2 marbles are chosen without replacement. Okay. The probability of selecting a black marble and then a white marble is 0.34. There's a key word there. I want everybody to underline the word black and white. Black and white. Those 3 key words. Black and white is 0.34, and then underline the 0.34. That was the first key. Now, it says black marble and then a white marble is 0.34. Yeah. And the probability of selecting a black marble on the first draw is 0.47. Okay, so I want you to write by that one. That's the given. Given for black. Okay. Now, if you'll notice underneath there, it wants to say, it says, what is the probability of selecting a white marble on the second draw, given that the first marble drawn was black? Now, if you look at this right here, you guys, we want to know the probability of, what was the first one? The probability of a white marble on the second draw, given that the first marble was drawn black. This is kind of like this, but it's, let's use white and black. Probability of white, given that black happened on the first draw, right? That's what it's asking. And that's equal to the probability of A and B, or the probability of white and black. Well, what it tells us right there, what is the probability of white and black happening? No. Of white and black, 0.34, right? Is that what you said? Okay. 0.34. That's the intersection. Remember the word and is an intersection? And in there I had you underline the word and, black and white. That's the intersection. And it's divided by the probability of a black, or the probability of the given. What's the given? 0.47. If I put that in my calculator, I get 0.72, which is equal to 72%. You can see it's all written out there, right? Do you think you kind of got the idea? So all you have to do is find the intersection and the given. You guys read number 2, and I want you guys to tell me what the intersection and the given is on that one. Okay, what was the intersection on this one, you guys? Absent and Friday, which is what amount? 0.03. That's the top number, right? And I divide that by the given. What's the given? 0.2. If I put that in my calculator, I get 0.15, which is equal to 15%. There's my answer. Got it? Getting the idea here? Look at the third one. At Kennedy Middle School, the probability that a student takes technology and Spanish is 0.087. 0.087 represents what, you guys? The intersection, 0.087. Divided by the given, 0.68. So what's the probability that someone takes technology given that they also take Spanish? 0.13, which is 13%. So bottom one?
Well, just all of them. Like, it already says that the probability of the student takes technology and Spanish is 0.087. Why do we need to know?
Because we want to know what the probability of someone that's taking technology given that they take Spanish. So basically, we want to know the people who are the probability of people taking technology given that they're taking Spanish right now.
Isn't that what the 0.087 is?
No, 0.087 is they're taking technology and Spanish. That's a bigger number. I mean, that's a smaller number of kids. Let's look at the Venn diagram on the next one. I think that will help you understand. Okay, you guys, there's a Venn diagram right here. Okay, the numbers didn't show up on here. I can't remember exactly what they are, but let's say this is 0.2, this is 0.3, and this is 0.4. That means there's going to be 0.1 out here, right? Okay. I want to know what the probability of B given A is. Here's A, here's B. We're going to look at a picture of it, okay, now. You guys, I know some of you guys are working on the assignment. Put the assignment away. You're going to have plenty of time. It's going to take you 2 minutes to do the assignment. Everybody look at the Venn diagram so you can understand this more in depth, okay? Put the assignment away right now. Look at the Venn diagram. I want to know, what is the probability of B happening given that A has happened? Well, okay, what area am I talking about? What's the probability of B happening given that A is happening? Well, let's do this. If I'm going to do probability of A and B divided by, because the probability of what? Probability of A, right? Because A already happened, right? Okay, because the probability of A, this is my total possible solutions. And this is some of the numbers that can happen in there, okay? So what is P of A? What's P of A, you guys? How much is that going to be? 0.5. Why? Because everything in A is 0.3 plus 0.2, which is 0.5, right? So my bottom number is 0.5. A and B is the intersection of those. What's the intersection? 0.2. Okay, now this is going to tell me what's the probability that B is going to happen given that A happened. Well, what does 0.2 over 0.5 come out to be? 0.4, which is 40%, right? That's the chance right there. In other words, 0.2 is in both A and B, right? But I could only choose from A to get probability of B given A, okay? Because A is what happened first, and I want to know all the B's in it, which is only 0.2, so 0.2 over 0.5, and that's the intersection. And that's a picture of what you're looking at on the other ones. Think about it for a little bit. You might want to fill those numbers in there, and that might help you understand it more in depth. Okay? Probability of B given that A happened. So using a Venn diagram might help you get that picture. Now, guys, you can go work on your assignment. There's 5 problems. Should take you about 2 minutes to do once you get the idea. If you don't have the idea yet, ask somebody what's going on. Just a reminder, you've got the extra credit assignment is due on Tuesday, and this assignment is due Tuesday. Okay, I don't want either one of them today. We'll turn them all in then. So if you're watching this home, come and get the assignment and the extra credit assignment from me.